These are AP Statistics notes on Venn diagrams. We're going to take a look at a situation where we have students taking algebra and biology classes, and we're going to let A be the event that a student is taking algebra, and B be the event that a student is taking biology. And we have some probabilities. We have the probability of A, that's the probability of a student taking algebra, is 30%. Probability of B, a student is taking biology, is 50%. And we have this probability of A intersect B, which means A and B, is 10%. Now, I'm going to use both the term intersect and here because when you're dealing with a Venn diagram, we do deal with this term meaning intersection. When we're filling in correct values, the first thing we want to look at is where circles A and B intersect. That's this middle region here, and we know that 10% of students are taking both classes. This is typically a value we're going to fill in first. And the reason that we're going to fill in this value first is when it says the probability of A is 30%, that's not this crescent moon right here, part of A, it's all of circle A. Everything inside circle A should add up to 30%. So if we've already accounted for 10% here, there needs to be another 20% here. That way, everything inside circle A represents 30%. So we basically have 10% of kids are taking both classes, just 20% of kids are taking just algebra, and then we have this region, the probability of B is 50%. That means everything inside circle B has to add up to 50. We've already accounted for 10%. That means there must be another 40% here for the entire circle B to add up to 50. Now, obviously, we have some students that are taking neither algebra nor biology. These are students on the outside, and we'll talk about them a little bit later on. In problems 2 through 9, we're supposed to find the probability appropriately shading the probability on the diagram. So the probability of A and B we've already dealt with is this region right in here in our diagram, and we've already established that this region here is 10%. For number 3, the probability of A or B, this is the term A union B or A or B, can be thought of to mean a few things. You could take it to mean anything that's inside the crescent region, this intersect region, or this region here. So one thing you could do is you could add these 3 probabilities together and get 70%, and that's a valid answer. The other thing that you could do is you can use the formula for unions. The formula for union says that the probability of A or B equals the probability of A plus the probability of B minus the probability of A intersect B. Essentially what we're getting at here is if you take everything inside circle A and everything inside circle B, you're including this middle region twice because you're adding it because it's part of A and circle B. We don't want to add it twice, so I'm going to subtract off one of the times that we kind of added it in here. Using our formulas, the probability of A is 30%, the probability of B is 50%, and the probability of both A and B is 10%. If you do 30 plus 50 is 80 minus 10, you get 0.70, so it matches up both times. A or B refers to anything inside circle A or circle B, including both regions. That's this entire thing in here. Number 4 is the probability of A complement. This is the probability of not A. Some people view it as being the 1 minus the probability of A. So we're going to take anything that's not part of circle A. That would include not only this crescent region here, but students that are taking neither algebra nor biology, so this region here. If we use the formula, the probability of A is 30%, so 1 minus this probability would be 70%. The other thing that you could do to calculate this answer is figure out how much stuff is in the outside plus how much is in that little crescent moon here for region B, that kind of part of region B that's not part of region A. We know these 4 probabilities altogether need to add up to 100%, so you can figure out that this region here is 1 minus 70%, which would be 30%. So you could also calculate 40 plus 30. That's another way of getting 70% as well. For number 5, A and B complement. Region A is referring to the entire circle. B complement is anything that's not in B. So and means it has to be inside circle A and it can't be in circle B. So we're not going to include this region. A and not B refers to this region right in here. Why is this the answer? Because it's part of circle A and it's not part of circle B. We don't include the region out here on the outside because it's not part of circle A. So what's in circle A and not in circle B? That crescent moon region, which is 0.20. This refers to not A and B. So it can't be in circle A, so it could be on the outside, or it could be this crescent part of circle B. And it has to be in B. So we're referring to this region right here. This region is part of circle B. It's also not part of circle A. We don't include the region on the outside because it's not inside circle B. So this crescent moon region right here, you may recall, is equal to 40% based on our diagram up here. Not A and not B. So it can't be in circle A, can't be in circle B. That must be the stuff on the outside. We've already established this region as 0.30. It's also the complement of everything on the inside, which was your answer for number 3. So you could take 1 minus 0.7 and get the same answer. Number 8 is A given B. So given we're inside circle B, what's the probability that we're in circle A? Now you can use our formula for conditional probability, which says that this is equal to A and B over the probability of B. We have already calculated these values here. The probability of A and B is 10%. The probability of B is equal to 50%. So you could do 10% over 50%, which is 1/5, also equal to 0.2. If we're talking about what region we're shaded in here, I'm going to use my highlighter for just a moment. We're just talking about circle B, so assuming that we're just inside this circle right here, what's the probability that we are inside circle A as well? So it's basically taking out of everything in circle B, which is 50%, what's the probability that we're also in circle A? So 10 out of this 50 is equal to 0.20. The probability of B given A is going to be the probability of B and A divided by the probability of A. Now the probability of B and A is still this intersect region, which is 10%. This time it's going to be out of what's in circle A. We've already established circle A as being 30%. So we're going to do 0.1 over 0.3. This is 1/3, or 0.3 repeating. If we're looking at what we would shade in here in our diagram, we're dealing with out of circle A. So assuming we're just working with the circle A region right here, what's the probability that we're also in this intersect region? So given we're in circle A, what's the probability that we're also in circle B? 1/3. Number 10 asks, are the events A and B independent based on the formula probability of A and B equals the probability of A times the probability of B? We've established that the probability of A and B, which we answered in number 2, is 0.10. And the probability of A and the probability of B were equal to 30% and 50% respectively. And I think it's pretty clear when you multiply these two values together, we are not going to get 0.10, we're going to get 0.15. So these values are not equal to each other, therefore the events are not independent. Now you could also verify using this other conditional probability rule. We said in number 8 the probability of A given B was equal to 20%. If the events are independent, this should equal the probability of A. We already know that's equal to 30%. These values are not the same, so the events are not independent by that rule either. You've just determined whether A and B are independent, and we've just established that no, they are not. What does this answer mean in the context of our problem? Well, in the context of the problem, we're wondering if taking algebra and taking biology are independent events. Apparently, based on our results here, whether or not a student takes algebra depends on whether or not they take biology. We said the events are not independent. Not independent is like a double negative. Not independent means it is dependent. So if a student takes algebra, it depends on whether or not they take biology as well. So the two probabilities are related to each other. That establishes how to set up Venn diagrams and answer questions using Venn diagrams. Hopefully you're able to figure out your homework assignment for tonight that deal with these Venn diagram problems.